Hey guys, welcome back to this channel. My name is Eric from Vatos Technologies. In this video, I will explain encryption in a simple way. So focusing on symmetric and asymmetric encryption, you will see how they work in a practical. So how keys are used and where each type of encryption is applied in everyday technology. So let's begin. All right, so if you look at this place, you said encryption, and encryption is used to provide confidentiality. So if you don't want your data to be altered by a third party, you don't want your data to be intercepted, or you don't want your data to be readable, so you have to do what? Encrypt it. So confidentiality, only intended recipient can interpret the data. So that's the reason we encrypt our data. So as you can see in this place, this is hello, and here it was encrypted into this ciphertext. Now, plain text means data before encryption and after encryption. So this is the data before encryption. So that is why it's called plain text. So data before encryption is called plain text. All right. So ciphertext is data while encrypted. As you can see, this guy here, this is called ciphertext. So before it was encrypted, it is called plain text, which is the readable one. This is hello, is the readable one. So it's called plain text, which is the one you can read. All right. The normal text we use. So this is the data before it was encrypted. So it is called what? Plain text. So after being encrypted, it is now called ciphertext, which is the unreadable one. So as you can see, you can't be able to read this. So why? Because it is now a ciphertext. All right. So you cannot be able to read it. It's unreadable. All right. So simple encryption transforms plain text into ciphertext. Now, that is what they call simple encryption. So this is example of simple encryption, which uses a public encryption algorithm to encrypt a data. So now, if this is hello and is encrypted to this ciphertext, which is LOHEL. So what if I send this to Mr. A? What if I send this to Mr. A and I want to send the same hello? All right. I want to send the same hello to Mr. B. That means it's still going to carry in simple encryption, is going to carry the same ciphertext that Mr. A received. Meanwhile, I want to send this to Mr. B. So I want to send this to Mr. B. It means that Mr. A will be able to intercept into this ciphertext because he's now familiar with this guy here. So this is why simple encryption is not secure, right? It's not secure because it uses the same encryption algorithm to encrypt a data. It doesn't change. So it uses the same encryption algorithm. So if I'm sending this hello to 30 persons, all those 30 persons are going to still receive this same ciphertext here. It's not going to change. So the ciphertext are not going to change. So it's still going to be this LOHEL. So that's the problem of simple encryption. It doesn't encrypt with a key. All right. So to solve this problem, this is where this guy enters, which is key-based encryption. Now, key-based encryption, it combines industry-vetted algorithm with a secret key. So this guy encrypts data with a secret key, which will be able to make the recipient to get a different ciphertext. As you can see, this ciphertext, all of them are different. Meanwhile, this is 3 persons and they are getting different ciphertext. All right. Meanwhile, the plain text are the same and the ciphertexts are different. So this is where key-based encryption comes in. So they encrypt according to they encrypt their data with a different algorithm, which means they encrypt with different keys. So that's why these guys are having what? Different cipher text. So Mr. A will not be able to intercept in this data. in Mr. B, this yellow orange will not be able to intercept into this purple orange data. Why? Because they have different encryption. So this guy is not familiar with this one. Meanwhile, this guy also is not familiar with this one. So they are different. So that's why this one is more secured. Encryption, key-based encryption is more secure than simple encryption. Remember, if this is simple encryption, they are going to have the same ciphertext because it uses a publicly known algorithm keys. It uses a publicly known algorithm to encrypt the data. So, but this key-based encryption combines industry embedded algorithm with a secret key, right? So this one uses a key to encrypt their data. So algorithm is created by the experts. All right. So secret keys can be randomly generated. All right. So you're going to understand this better when we enter the practical. All right. So now encryption. So there are two types of key-based encryption. All right. There are two types of key-based encryption, which is the secured one. So number one is symmetric encryption, which it encrypts and decrypts using the same key. So this guy encrypts and it encrypts and decrypts using the same key, right? Okay. So the second one is asymmetric encryption, which encrypts and decrypts using different keys. Using different key. This guy uses the same key, which is asymmetric encryption, which is symmetric encryption, while asymmetric encryption uses this different key. All right. So let us enter the practical so that you understand exactly what I'm talking about. All right, guys. So let's quickly do the practical for symmetric encryption, right? So all right, if our plain text is something like hello, let me just say hello, right? Let me just say hello. Let me just put them in practical and capital letter. Let me just say hello. So if this is my plain text and I want to encrypt this guy, remember what we are encrypting is symmetric. We are using the symmetric encryption type. All right. So and I want to encrypt this guy. All right. So if I want to encrypt this guy, so let me just say encryption key. Let me just say encrypt. Oh. So if I want to encrypt this guy, if I want to encrypt this guy, let me say the encryption key. So let me say the encryption key encrypt encryption key is equal to 3. All right, so let's do that. So to decrypt this guy now, what we're going to do is that um from this alphabet, we want to decrypt this hello. So we are using the encryption key of 3. So I want to explain this in a layman's understanding so that everybody will understand this thing. All right, so if I want to encrypt this hello and we are using the encryption key, which is 3. Now, remember, this is symmetric encryption and it uses only one key to encrypt and decrypt. All right, it uses only one key to encrypt and decrypt. So this key now is what they call secret key. So let me just write secret key here. Let me just write secret. Let me just say secret key. So this is the secret key. So this is the secret key, all right? So if I want to encrypt this guy now, this hello, all right? So what I'm going to do is that, let's come to this place. So what we have here is H, right? What we have here is H. So, and I'm using the encryption key of 3. So we are going to count from this H. So we are going to count from here. So we now say 1, 2, 3. So that means let's write key here. Let me just write all so that I will explain later. Now, how did we get this? So let me show you how we got this. So remember, we have hello here. So we now, and we are using the encryption key of 3. So we count from this H. After this H, you now start counting from I to K. So this is 3. That's how we got this key here. All right. So the next one is H. So when you go to H, sorry, the next one is E. So you count from F, 1, 2, 3. So that's how we got this H here. All right. So the next one is L. Where is L? This is L. So if you count from this L to the next 3 letters, that's O. That's how we got this O. And the next letter is also L. We got another O. All right. And the next letter is O. So where is O? So this is O. So if we start counting from here, we got R. So this is how we got this R. So this is the cipher test of this hello. Now we are using encryption key of 3. So now we are using encryption key of 3. All right. So let us quickly do another one. So now, if we want to decipher, now this is the cipher test, right? This is the cipher test, and this is the plain test. So if we want to decipher this guy now, if we want to decipher this guy, which is we want to decipher this guy. So let's also say K H O O R. All right. So to decipher this guy now, what you should do is to come here. Since the encryption key, remember that both this is asymmetric encryption, this is symmetric encryption. The encryption key is a secret key which uses the same key to encrypt and decrypt. Now we are going to use the same key, which is encryption key of 3, to decrypt this guy. So to decrypt this guy, now let us decrypt this guy here. All right, let us decrypt this guy here. So let me first of all put so don't worry, I'm going to show you how we got this, right? So now remember our decryption key, we are still using decryption key of 3 because this is symmetric encryption, which uses the same key to encrypt and decrypt. So now we are going to use the decryption key of 3 to decrypt this guy. So we are going to go backward. As you can see, this arrow is facing forward here. This arrow is facing forward, and this one is facing, this one is facing right forward, and this one is facing backward. So this is what happens in symmetric encryption. So now, since we decrypted with 3, with encryption key of 3, we are still going to decrypt with encryption key of 3, all right? Which will be also our secret key, because this one uses one key to encrypt and decrypt, which is the secret key. All right, so to encrypt this is H. So how did we get this test here? So this is H, this is K. So this is K. If you count back, you will get H. That's how we got it again. And this is H. This is H. So if you count back from H, you get E. That's how we got this E. That's how we got this E. So this is O. If you count back from O, you get L. That's how we got this L again. So this is O again. If you count back again, you get L again. And this is R. If you count back from R, where's R? Count back from R, we get O. So that is how we were able to decrypt this guy here. So this is symmetric encryption for you. All right. So now, what if we want to encrypt the word "com"? All right, we want to encrypt the word "com". So let's say "com". We want to encrypt this word called "com", right? So we want to encrypt this word called "com". So and we are using the same encryption key of 3. So how are we going to do that? So let us come here. Let's come here and put our word here. So this word is called "com". So the first letter is C, right? So what you do is just to count from this C, you count to F, all right? So you come to this place. You come to this place and write your words F. So you come to O and you come from P to R, all right? P to R. So you come to this place and write your R. You come to this place and write your R. So we are encrypting it now. So when you come to this M, which is this guy, you come from here to P. You come from here to P. So you come here and put your word P. So you also come to this E. You also come to this E. You come from F to H. So you come to this place. You come to this place and put your word E. So F to H. Come to this place and put your F. As you can see, this is now the cipher test. This is now the cipher test. Remember, we are using encryption key of 3. If you are using encryption key of 4, if we are using the encryption key of 4 instead of 3, so as we have this come here, what you now do is to come here and come from here to 4, which is G. So this F now will now be G. All right. This F now will now be G. So this is how it works. If you are using encryption key of 7, all right. If you are using the encryption key of 7 and you want to encryption key of 7 instead of 3, and you want to decrypt, you want to encrypt this com. So when you come to this C, you come from here to 7, which is here is 1, 2, 3, 4, 5, 6, 7. So this it will no longer be F or G. So it will now be what? J. So that is how you do it and encrypt it. So if you also do it backward, that is how you also do what? Decrypt it. So now let us also decrypt this com here. To decrypt this guy, this com, this com, we have encrypted it using this encryption key of 3. So if you want to decrypt it again, you have to count back again. So if you want to do that, so this F now, which is this guy, so just come here and count back, which is C. So you come here and write your C. All right, you come here and write your what? C. So you come here and write your C. So that is it. So this R, if you come to this R and you count back, that is where you get your O. So you also come here. You also come here and write your words. O. So you come to this P. So if you count back from P, 1, 2, 3, so you get your M, right? Which is this guy. You get your M. So that is where you come here and put your M. So if you want to do for this H, so what you do is from H, you also come back to 3. So you come here and put your what? Put your what? E, which is E. So you now get your come back. So that is how you encrypt and decrypt. All right. This is for symmetric encryption, right? So you use the same key to encrypt and also use the same key to decrypt. So in asymmetric encryption, which you're going to be entering now, you see that it should be a little different. All right. It should be a little what? Different. So quickly, let us enter asymmetric encryption so that you see how that one works. All right. All right. This is asymmetric encryption. As you can see, our plain text is hello and our encryption key is 5, while our decryption key is 21. So remember, this asymmetric encryption uses the different key for both encrypting and decrypting. So to encrypt, the key is called public key, and to decrypt, and the key is called what? Private key. All right. So now let us decrypt this. All right. So the encryption key is 5. All right. The encryption key is 5. So let's quickly decrypt this. So if you have this hello here and you want to encrypt this, so what we say is this is H, right? So let us count again. So this is H. You now count from this I, from this guy, 1, 2, 3, 4, 5. So this is how. So what we now do is to come here and put our words N, which is N, right? We got it, which is our N. So the next one is E. So we come here, we count our E, right? So we count from E, 1, 2, 3, 4, 5. So we put our what? J here. We put our J here. So we now do for the L. So to encrypt this, so we count from here to 5. 1, 2, 3, 4, 5. So which is what? R. So put our R. It's like we're making a mistake. So this is L, right? Let's do it again. Let's do it again. This is L. So we count from M. 1, 2, 3, 4, 5. So it should be Q. Should be Q. Where is Q? This is Q. So if you do it again for the second L, we also get Q. So if you do it for O, this is O. So let's count. This is O. So you start counting from P. 1, 2, 3, 4, 5. Right? All right. So we put our T here. So this is how to encrypt this. So this is how to encrypt this. Are you with me? So now to decrypt this, we are going to use the decryption key of 21. Now, this is where it gets tricky. This is where it gets tricky. So for instance, let us put our hello here. Okay. Or let us decrypt this guy. Let us bring this guy down and decrypt it. So let's just say M, J, Q, Q, and T. So let us quickly decrypt this guy here. Right, so let us quickly decrypt this guy. So to decrypt this guy, we are using the decryption key of 21. So now I made a mistake in this arrow. In symmetric encryption, the arrow goes front and back, which means you decrypt by going front and you encrypt by going front and you decrypt by going back. But in asymmetric encryption, it doesn't go back. So I made a mistake in this arrow. So it's supposed to be forward ever. Supposed to be forward ever. All right. Yeah, supposed to be forward ever. I don't know. This shouldn't. Let me do it again. So it's supposed to be like that. All right. So I made a mistake. I made a mistake. So let me do it from here. If I also do another one. Okay. So it's supposed to be forward ever. All right. It doesn't go back like symmetric encryption. So this is asymmetric encryption. So it keeps going forward. So to decrypt this guy here, so what you're going to do is to come here. So let us decrypt this guy now quickly. So this is M. All right. So to decrypt this guy, what you're going to count is 21. All right. So this is to decrypt this guy, we are going to count 21. So we are not going to go back like symmetric encryption. So let us count from N. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. 14, 15, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right. So we got our H. So let us put our H here. So this is J, right? So our decryption key is 21. So let us count again. Let us count again. So let us, this is J. So let's count again. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. What am I counting? God. Okay, this is 16, right? This is 16. From K to Z is 16. 17, 18, 19, 20, 21. So we got our E, which is the 21. Okay. So I just want you to understand it. That's why I'm taking it gradually. All right. So let's come to Q. Let's come to Q and continue our journey. We don't go back. Remember, we only go forward because it's asymmetric encryption. All right. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we got our L, which is 21. All right. So I made a mistake here. So let's put our L. So if you do another one, another Q, you get an L. So for this T, okay, let's quickly do this T. Let's quickly do this T. So where's the T? Where's the T? So let's count 21 again, right? From U, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we got our O. So let's quickly put our O. So as you can see, we have successfully decrypted this guy. So we still have the same hello. All right. We still have the same hello. Now, I want you to pick up your pen and pick up your jotter. So I want to say something that is vitally important. You should write down. Now, in asymmetric encryption, because I don't have time to write this thing down. In asymmetric encryption, there are certain things you need to know. Number one is two different keys that are mathematically related. Now, you see that if you are sensitive, you should be able to know that this encryption key of 5 is mathematically related to this decryption key of 21. How? Because this alphabet is 26, right? This our alphabet is 26, right? So if you minus 5 out of this 26, you get 21. So that is one thing you should know. So if you minus 5 out of this 26, you get 21. So if you're using encryption key of 5, that means our decryption key must be 21. Are you getting me? So another thing you should know is that what one key encrypts, only the other can decrypt. So if we use encryption key of 5 to decrypt this hello, it's only the decryption key of 21 that can decrypt this guy back to hello. Are you with me? So if I use encryption key of 4 here to encrypt, remember this is asymmetric encryption. If I use encryption key of 4 to decrypt, that means our decryption key will be what? 22. Our decryption key will be 22. So it's only the decryption key of 22 that can decrypt it. So I want you to do this as an assignment. Do it as an assignment and submit it in our WhatsApp group, or just submit it in my DM. All right. If you submit it in my DM, I'm going to post it in our main group WhatsApp. So now, if I decrypt this guy with 21, or let me say, if I decrypt this guy with 21 here, let me just say, if I decrypt this guy with 21 here, that means, sorry, if I encrypt this guy with 21, it's only decryption key of 5 that I can use to decrypt it. 5. So it is mathematically related. All right. So there is no other key that I can use to decrypt this guy except the key of 5. Are you getting me? So if I encrypt it with 10, so the remaining numbers is what I can use to decrypt it. So it is mathematically related. So if I encrypt this guy with 1, I will use so the decryption key will be 25. And if I encrypt it with 25, that means the decryption key should be what? 1. So that it will round up the 26 digits of this alphabet. So it is mathematically related. And note that what one key encrypts, only the other can do what? Can decrypt. Now, one key will be made what? Public. So this guy is called public. Let me just use this guy here. I don't know, but so this guy is called what? The public key. Should I write it? So this guy is called the public key, right? Let me just write it down. The public key. Okay. So the encryption key of asymmetric encryption is called what? The public key. Why the decryption key is called what? The private key, or you can also call it secret key. You can also call it private or secret key. All right, so maybe in our more to come videos, I'm going to dive deeper into the complex cryptography. If you don't understand this simple practical cryptography of symmetric and asymmetric encryption, just know that you cannot be able to understand cryptography again in your life. So this is the simplest practical cryptography tutorial you will find in the internet. All right, so let us go back to our slides. So I think this is the next one, right? All right. So now let us see the weakness and the strength of this asymmetric and asymmetric. So for asymmetric, it has weakness, which means the is low, is lower, which requires much larger key size. Meanwhile, the symmetric encryption the strength is that it's faster with lower CPU cost. So now the weakness of this guy again, which is the asymmetric encryption, is the cipher text expansion. All right. But this the strength of this guy is that the cipher text is same size as a plain text. So it means that if the plain text is 5 words, all right, the cipher text is going to be also in 5 words. But this guy has a cipher text expansion. If the plain text is 5, that means the cipher text might be bigger than 5 or even 15 to 20. That's why this asymmetric encryption is more secured. It's more secure, but symmetric encryption is more faster. But this guy is more secure. So the weakness of this symmetric encryption is that secret key must be shared, which is less secure. But the strength of this guy is that private key is never shared, which is this guy. Where is it? Which is this guy? Which is this private key is never shared. Don't share it to no one. All right. All right. So let's go back to this guy. All right. This is encryption. So this is asymmetric encryption algorithm. All right. So the first one you have here is a DSA, which means digital signature algorithm. So this one is only used for digital signatures, right? So not for encryption data. So it's just for digital signatures. So the next one you see here is the RSA, which means Rivest Shama Agleman. So that's the meaning of it. And this one is just used for encryption and digital signatures. Or the next one you see here is Diffie-Hellman, which is used to securely exchange keys over an insecure network. But I don't have time to explain these guys here. So the next one is this ECDSA, which actually means elliptic curve digital signatures algorithm. All right. So this one is just faster, more efficient version of the DSA. So it's an efficient version of this guy here. It's an efficient version of this guy here. All right. So the other one is ECDH, which actually means elliptic curve Diffie-Hellman. Right. So what you should know about this restricted to limited data is that because asymmetric encryption is computational, expensive, and slow. So that's why it's restricted to limited data. So that's why you don't use this. If you want to encrypt much data, big data, it should be recommended you use symmetric encryption instead of this guy. Though this guy is more secure, all right? So we will enter this symmetric encryption. So this guy, the algorithm for this guy is DSE, which means data encryption standard, which uses a 56 key, 56-bit key, all right? Insecure and obsolete. This one is insecure. That's why it's on red ink. Okay, that's why it's on red ink. These two guys, they are on red ink because they are not really secure. So this green one means they are very, very secure. These green ones means they are very, very secure. All right. So we also have this ROC4, which means Rivest Cipher 4. All right. It uses 128-bit key. It's not still secured. So the other one is 3DSE, which uses 168-bit key. It means that this 3D ES actually means triple des. All right. Triple des. So this one is a triple of this guy. This guy here is the triple of this guy. So if you plus this guy in three places, you are going to get 168-bit key. So that's why it's called triple des. Triple des. All right. It applies des 3. It applies this guy 3 times. All right. So that's why it uses 168-bit key. So it's more secure than these days, right? But slow and outdated. So we have this one. This is which is secured. Is written on blue ink, green ink, which is AES, which means Advanced Encryption Standard. So this one is industry standard. It supports 128, 192, or 256-bit keys. All right. So, and this the other one which you have here, which is Charter 20, which uses 128-bit key. So this one is modern. This one is modern. This one is modern. All right. In our modern days, it's often used, which has high performance cipher, excellent for mobile and low power devices. So this is cool. So in our upcoming videos, we'll be practicalizing these guys. Okay, we'll be practicalizing these guys here. All right, guys. So that's it. That's the basic explanation of symmetric and asymmetric encryption using practical examples, which you saw here. All right. So if you now understand how encryption protects data, please then this video has done a great job for you. All right. This video has done a great job for you. So don't forget to like this video, subscribe for more simple cybersecurity lessons, and I will see you in the next one. Please just like and subscribe to our YouTube channel. All right. See you in our next video.